Alright, hello everybody. Today's lesson is going to be about the angles of a triangle. You probably know some things about a triangle already, but there's lots of things you probably don't know as well. So we'll get straight to it after I apologize. I'm doing this in a car, which is a terrible learning environment, but it's where I am and we'll get it done. Hope it doesn't distract you too much. Alright, so a triangle is a polygon. A polygon is a many-sided or a many-angled shape. But a triangle has three sides and therefore three angles, which is probably not a news flash to anyone here at this point in time. There are three segments. Those are the sides. Over here we have segments XY, XZ, and YZ. Triangles are made up of segments and that are joining three non-collinear. If you really think about it, if they are collinear, then you can't make a triangle. Those three non-collinear points are the vertices of the triangle. We have vertex X, Y, and Z over here. Those 3 points. Each of them is called a vertex. And so we have three angles. We have angle X, we have angle Y, and we have angle Z. So those are all of the pieces and parts that we're going to be talking about of the triangle. Now, classifications of triangles. Triangles can be classified two ways. Now, every single triangle can be classified by one of these, by each of these categories, by their sides or their angles. So, when we're talking about sides, it's the number of congruent sides. These are terms that you've probably heard before. Scalene means there's 0 congruent sides. So, now, you can draw it to make it look like there's no congruent sides, but if you want to tell me that there's no congruent sides, use the markers. The fact that this has 1 mark, this has 2, and this has 3, that says without a doubt that these three sides are different lengths. So that's how you'll communicate that. Isosceles is a type of triangle where there's 2 congruent sides. So when you draw it, you'll want to have 2 sides that are marked the same way. Just one more example here of it. The number of tick marks you use doesn't really matter. Don't be obnoxious, of course, but if it's isosceles, 2 of the sides better have the same number of tick marks. An equilateral triangle is one with 3 congruent sides, and so that's what that would look like. Now, angles. When we're talking about the angle, to determine what type of triangle it is, you'll look at the biggest angle. So an acute triangle is a triangle with 3 acute angles. The largest angle is going to be acute. Okay? No matter how you draw an acute triangle, the biggest one will always be acute. An obtuse triangle is where there's 1 obtuse angle. If you think about it, there can only be 1 obtuse angle. But we'll get more into that in just a little bit. And so if there's 1 obtuse angle, there's 2 acute angles. A right triangle is one where there's exactly 1 right angle and then 2 acute angles. Okay? So to make an obtuse triangle, there's only 1 obtuse angle, and a right angle has only 1 right angle. Every triangle has at least 2 acute angles. Now, the last type here, an equilateral triangle, actually, that slip might make sense. An equiangular triangle is one with 3 congruent angles. They're all going to be 60 degrees, and if you haven't, I'll go ahead and just share this. An equilateral triangle is an equiangular triangle. An equiangular triangle is equilateral. Those two things go together. So when we say equilateral, we also will mean equiangular. But that's a special type of angle version. So what I'd like you to do is try to draw these 4 types of triangles down here below. Pause the video if you didn't. Try those 4. Alright, when you're going to draw a right triangle or an obtuse triangle, start with the right angle. Now, for it to be a right isosceles triangle, the 2 isosceles pieces are going to come off of that right triangle. So draw a right angle, make the 2 isosceles sides, and then connect those dots. It will never be like this. The 2 congruent sides can never be well, one of them can't be opposite the right angle. An acute scalene triangle That's probably one of the more basic ones. Just be careful. This angle here is almost a right angle, but it's not. It's less than a right angle. And if you want to mark them as scaling, put those markers in there. Equiangular, equilateral, mark those angles. Same thing with which other right triangle. If you can draw an isosceles obtuse right triangle, or obtuse, an isosceles obtuse triangle, start with the obtuse angle with those sides. Now, some of you are familiar with this because we've discussed it. A triangle sum theorem is this. The sum of the angles of a triangle is equal to 180 degrees. Now we can say this without a doubt. I'll do a proof for this later for you. But if we have this, it's example A down here, find the value of x, then those three angles, x plus 3x plus 80, the sum of those is equal to 180. So now, you just write that equation and solve for x. 4x plus 80 equals 180, 4x equals 100, so x equals 25. If I plug the 25 back into the triangle, I get 25, 75, and 80. If you add all those together, they equal 180. And it better work that way. Here's a different example over here where we're going to find this missing angle up here. To find this missing angle, I know this is 27 degrees. I need to know what this angle here is, right? Well, don't have enough information in that single triangle, but look, it's vertical to this triangle down here. So to find, before I can figure out what this angle is, I need to figure out what this angle is in this other triangle. 35, 23, and what? Well, 180 minus those gets us 122. So I will put the 122 here in this triangle, which means this angle is also equal to 122. Those are vertical angles, of course. And so now I can subtract these two angles, 27 and 122, from 180 to get my answer, which is 31 degrees. So sometimes you have to use information from another triangle. So try these 4 questions down here, applying this triangle sum theorem. Pause the video, give it a shot. Try these triangles. Will you write the word try above the word triangle up here for me? Write the word try. So you had hopefully those 3 answers. And did you write this equation on number 7? X plus 2x plus 3x equals 180, and then solve that and get 30? I surely hope you did. Now, there's 4, they're called corollaries. These are things that are true because these other theorems are true. A couple of these already talked about. But these are things that you're going to need to know. If 2 angles of one triangle are congruent, then the 2 angles of another are congruent to 2 angles of another triangle, then the third angles must be congruent. Think about this for a second. In this triangle up here, if these 2 angles are here are both equal to 85 in these 2 different triangles, these 2 angles here are both equal to 55 in these 2 triangles, then these other 2 angles have to be congruent as well. So if 2 angles of this triangle are congruent with 2 angles of this triangle, these third angles have to be congruent. That's the first corollary. Each angle of an equilateral triangle or equiangular triangle has a measure of 60 degrees. I mentioned that earlier. Here's why. If you have an equiangular triangle, they're all equal to the same thing. In this case, I've said they're equal to n. Well, 3n equals 180, so they each have to equal 60 when you divide by 3. Corollary 3. In a triangle, there can be at most 1 right angle or obtuse angle. Now, think about this one for a second. They have to add up to 90 degrees or 180 degrees, right? The triangles have to add up to 180. Well, if you have a right triangle, if you have 2 right angles, 90 plus 90 equals 180. Well, what would you do with the third one? You can't. So if it's obtuse, more than 90, well, you get the same idea. You get even more than 180 degrees with 2 angles. So there can only be 1 right or obtuse angle. This one's going to be really important. The acute angles of a right triangle are what? Well, think about this for a second. I got a right angle right here. That's equal to 90 degrees. So these other 2 angles, 180 minus this 90 is going to equal what? 90? Yes. So these other angles have to add up to 90 degrees. They are complementary. The acute angles of a right triangle are complementary. All right, use that idea right here and see if you can answer these 3 questions. Did you get these answers? This is just really, were you paying attention to those corollaries or not? Ends up being pretty simple in theory. All right, down here, this is the most unusual part of this lesson, probably. Talking about an exterior angle. It's formed when one side of a triangle is extended. And then there's remote interior angles that are relative to an exterior angle. They are the other 2 angles. Let's look at an example. Here in this triangle, angle 4 right here is formed by extending this lower side. We can extend any of these sides in any direction. The same thing applies. But angle 4 is the exterior angle, and then angles 1 and 2 are the remote exterior angles of angle 4. If I were to have extended a line over here, then angles 1 and 3 would be the remote interior angles of whatever exterior angle I had over here. So it all depends on which angle we're talking about. Here is the theorem. This ends up being really simple once you grasp it. The measure of an exterior angle of a triangle is equal to the sum of the measures of the 2 remote interior angles. So check this out. If the 3 angles of this triangle all add up to 180 degrees, I'm going to do a mini little proof over here for you. These 2 angles right here are supplementary because they are a linear pair, angles 3 and angles 4. They also add up to 180, right? Well, angle 1 plus angle 2 when added to angle 3 equals 180. Angle 4 when added to angle 3 equals 180. We could use substitution and subtraction pretty easily right here to prove that angle 1 plus angle 2 equals the measure of angle 4. That is how the exterior angle theorem works. In practice, how's it going to work? Well, look at example C down here. 4x is an exterior angle. These 2 angles are the remote interior angles of 4x, the 2 angles that are furthest away from 4x, the one that's not a linear pair with 4x. So therefore, 4x equals x plus 120. The equation ends up being that simple. So 3x equals 120, x is 40. Example D over here, we have to solve for both x and y. Well, I have a 90-degree angle and y. Those are the remote interior angles of this 150 degrees. And then x is just simply a linear pair over here. So it ends up being multiple ways we can get there. But 150 is the exterior, 90 and y are the remote interior. So to solve for y, we can say the 150 degrees equals 90 plus y. So y is equal to 60. To solve for x, we can say that this is simply a linear pair. 150 plus what equals 180. Or, now that we know that this is 60 over here, 90 plus 60 plus what has to equal 180. So there are just multiple ways that you can get these answers. All right, so try these examples down here and using the ideas that we've just been talking about. Pause the video and see how you do. All right, so 11, 12, 13, and 14 is just a pretty simple version of this remote or the exterior angle theorem. Okay, then 15, 16, 17, 18 on here, you got to apply, several of these ideas that we've been doing. Did you see that we have alternate interior angles down here in number 17? Parallel lines. When you see parallel lines, oh my goodness, alternate interior angles are going to happen. Same side interior angles are just going to happen. Speaking of same side interiors, are you noticing them on number 18? If you didn't, pause the video again and try it. So 17, the answer is 45 and 95. On number 18 down here, 140 is an exterior angle for y and 90. So you can figure out y that way. X is a same side interior angle of 140. Okay? So there's several different ways to get there. Also, if this is a 90-degree angle right here, so will x and 90 add up to 90 degrees. I'm sorry, x and y will add up to 90. All right, the end of the quarter is looming. I know we all need some rest. Get some.